The project on a whole looks to explore L systems as a means of city generation. Modern day cities are becoming more culturally and structurally diverse, with a few key styles being obvious and explored from the research report. To emulate a grid city like New York, for example, the structural foundations must exist through 90-degree road turns and evenly dense building arrangements. Any type of random string containing the values from A to E could be entered here, with A meaning forward extensions, left and right being B and C turns respectively, and D and E utilising backtracking that the L system can then combine their contents and translate it into a sort of riddle network. The longer the seeds, the more one can expect the city to be larger in surface area. The seeds entered here not only contribute to the illustrated city outcome, but also towards how the city is generated. The 90-degree road turns are specified by the user help to achieve the grid-style network, as it specifies how the roads need to interact with each other. With a slight change to the degree input, the city can be altered accordingly. As we go through some generations, even linear cities can be identified from that seed. However, having the ability to read and write from the city will also provide an interesting extension, as well as focusing on capturing city densities would be a good way to create more accurate city representations. Achieving a spiral city is also as easily achieved through means of sharper road turns and longer road segments. However, at this stage, the density for spiral cities is not yet captured. Note that the city here is not aiming to be like for like with city styles such as Paris, as given in the examples, but it tries to go some way in achieving the parameters that these cities incorporate. The red segments you see here is not the road layout that has been generated by the line renderers, but they are the colliders that have been placed over the top. The problem here was that the convex colliders attached to the line renderers would not accept any collision with building placement. So for each road generated, a collider would be placed at its centre and then pass through with the road angle at that instance. This then fixed the issue with the building spawning on the road. As we step through the code and navigate to the create collider function, steps were taken to ensure that the centre of each road segment was calculated. The angle was then found and compared against the error checking criteria to ensure that the collider was not offset. The angle was then adjusted to make sure it aligned with the current road segment.